Okay, so in this example here, uh, we're dealing with a rational function where the numerator has degree that is either larger than or the same as the denominator. And when that happens, we actually want to start the problem off with long division. All right, see, our ideas really could fall apart right here with letting u be x minus 2 and trying to work the problem out. All right, we would kind of run into a little bit of problems, up here, as far as how do we handle all the stuff that's extra and left over. So instead, what we do is we use polynomial long division to reduce this down to where the numerator has smaller degree than the denominator. And so it might have been a while since you've done polynomial long division, so I'll try to point out the ideas as we're going through here. So very important, if the polynomial that you're dealing with has a gap between powers, that you would want to leave an empty space for that. In this case, we don't have that issue because we have x squared and we have 3x. And then remember the steps for regular long division: divide, multiply, subtract, bring down. So the first thing to do is divide. So we ask, what would we have to multiply x by to get x squared? And the answer is, I'd have to multiply x by x. So now what we're going to do is take that x and multiply by the whole x minus 2 term. All right, we're going to take x times x minus 2. And so we do that. So x times x will be x squared. X times minus 2 will be minus 2x. So we've done the multiply step now. And now we want to subtract that off. So what that means is we're going to go through and change the signs here. So subtract, so that becomes negative, and that one would become positive. Now the x squareds will cancel out. We have 3x plus 2x will be 5x. And then we repeat the process until we can't divide anymore. So we would say to ourselves, what do we have to multiply x by to get 5x? And also, if there was anything extra left over here, we would bring that next term down. Okay, so x times 5 will give me 5x. So we go up here and write plus 5. And then we multiply, right? 5 times x minus 2. So 5 times x will, of course, be 5x. 5 times minus 2 will be minus 10. And then we remember that we're subtracting. So again, we change the signs. That becomes negative. That'll become positive. Again, the 5x's will cancel out. And actually, hold on here. Hold on. Yeah, I'm on the right track. I'm sorry, my mind just stopped for a second there. Okay. So, and then we have 10 left over. Now, x cannot go into 10 evenly. All right, we'd have to multiply by some kind of fraction. So that's my remainder, 10. So this will now be plus 10 over x minus 2. Plus 10 over x minus 2. And so now we can go back to the integral now that we've done our long division, because now the fraction is a fraction where the degree of the numerator is smaller than the degree of the denominator. In fact, in this case, it's a constant. So going back to my full integral now, I would have integral of x plus 5 plus 10 over x minus 2 dx. And of course, the integral of x is just x squared over 2. The integral of 5 is just 5x. The 10 is a constant and it will carry through. And then that's 1 over x minus 2, Well, 1 over x minus 2, if you let u be x minus 2, then du would call for a 1 to go with the dx, but we already have that. So that's just 1 over u. Integral of 1 over u is natural log. So this would be 10 natural log absolute value of x minus 2 plus a constant. Plus a constant. And so there we are. There we are. So we use long division to break it down so that we have a simpler fraction to work with. And then we can go from there. Okay, so that's the idea if we ever have a situation where the degree of the numerator is bigger than the degree of the denominator. Let's do long division and then integrate the result. And particularly if you have a denominator that's a first power, then you're going to have an integral that's relatively easy to work out.